What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hey everybody, welcome to Charlotte IoT. I'm stoked for an awesome meeting tonight. We have Brian Vinson from Google Cloud IoT. Pure awesomeness. It's going to be a great night. And if you guys have never heard of Charlotte IoT, we're like the best group in Charlotte, maybe the world. But we've done 64 meetings, which is like a number for me that's meaningful because any power of 2 is like incredible. 2 to the 6th power. Love it. And we just really accelerated on our growth and the types of things that we're doing and really having fun. We do lots of technical talks and lunch and learns, and I'll go into more detail on all of those. So this group is like incredible because we have this board that does epic things, and it's a board of 10 people, and there's lots of other volunteers who help out a lot and are contributing and making us like an awesome group. So it's way more than like 1 person or 2 people. It's this awesome board here who's carrying the group and doing great things. And we have Facebook and Instagram and a YouTube channel. So we're streaming live on YouTube. And Joseph, I want to thank you for streaming us. And I've got a slide I'll talk about in just a second, but we're also streaming all the way to Lake Norman. So if you live north of town, you no longer have to drive all the way to Charlotte IoT. You can go to the North chapter and see our meetings there and have pizza and everything in those meetings. We have a Slack channel. And if you're not on Slack, then go to Meetup, and after you enter your profile, put in your email and you'll get an invite to Slack. It's really great. You can ask questions. There's lots of senior people who love to help. Or we can set up rooms and if you have a particular interest. So it's a really great way to interact with the group. And Mike's set up the integration for that. Thank you, Mike. So our sponsors tonight is my company, Logical Advantage, and we're going to be making a big announcement soon, but I can't quite make it yet. But so I'm one of the co-founders of Logical Advantage from 15 years back, and SnapAV has been an awesome sponsor of the group, and I did put your slide in, Graham.
Want me to talk for a second?
Yeah, please do.
How many first-timers here tonight? Okay, good. So just a quick talk about SnapAV. We're a manufacturer and distributor of quite a number of audio-video pieces of equipment that people install in their homes. And so our interest in Charlotte IoT stemmed from like 4 years ago, I think is when we first met Dan. And because we have a cloud-based platform called Oversee that I happen to run. And so that platform is serving almost 2 million devices in the field, and it's kind of an exciting thing. And we're growing our development team, so I am looking for some developers, senior developers, both front-end and back-end. We're heavily invested in Google's Golang, and we're also converting things to React. So if you know anyone or you yourself are interested, let me know. So, but welcome everyone.
Yeah, if you guys are looking for work, I think it'd be awesome to work for Graham. He's been real supportive of the group, and if he's like that for us, just imagine how it'd be to work there. But they've got a neat architecture, and he's reviewed the architecture before. And one thing he didn't say that he always says, he always talks about like, we got another 100,000 devices online this month, and they've got like over 1 million devices in their cloud with Oversee. So it's pretty incredible stuff, and I think it'd be a neat company to work for. 2 slides for Snap.
There you go. That's what it is.
Yeah. So, and then a little commercial for my company. We've been doing IoT a long time. We've been doing enterprise apps a long time. This is a smart city app we did for the first one was the city of Toronto. It's now in more than 100 cities. I forget the count. RFID tracking of all the trash bins tied to the addresses and read by the trash trucks so that you can bill people based on their trash or recycle and that type of thing. We also focus on manufacturing, and I brought this in here from a manufacturing project we did that these spindles are spinning really fast. We built a piece of a breadboard that's monitoring inputs from the PLC that are monitoring the spindle spinning real fast. And we're pushing the data in the cloud where we can do analytics. We can let them know utilization data, and eventually we're going to get to predictive maintenance. But right now we're just trying to get an ass load of data so we can do cool stuff later on. And this was like a really fun project for us. And Particle, who makes modules for IoT, and they're really big in the makerspace, but they're also big in enterprise space. They did a case study on us. And they also are coming out with their third generation stuff. Raise your hand if you guys have ordered any of the third generation Particle. I knew Jeremy and Mike, you guys would have to. So like their stuff is really incredible. It's third generation is using Thread. And we're about to win a project that's implementing some of that, and we're just kind of stoked to use their stuff with it on a mesh platform in manufacturing. And we are also hiring, so if you don't want to work for Graham, come talk to me. And we always need DevOps people, and so talk to me at the end of the meeting, or if you have friends who are like kick-ass in DevOps, especially in cloud platforms, then please talk to me. So we are now in Lake Norman, and we're streaming live to you guys. Hey, Lake Norman. And we're also streaming live on the internet. And so people are going to meet in Lake Norman for our monthly meetings. And since we've got killer content, you won't have to brave the traffic. Mike travels from Raleigh, and Michael did too. Yes?
Just wondering if Lake Norman is using any chat mechanism to feed back to the group, because I mean, one way is nice,
yeah,
but two-way would be.
Joseph, can you answer that?
No.
So we talked about it, and there was a meeting, and I just couldn't attend it, so I didn't even know the answer. Okay. But yeah, maybe we'll get to use Zoom or something like that, where they can interact and maybe poke little messages on the screen and things like that. So our next Lunch and Learn is November 13th, and this one's more on the business side. It's everyone who's interested in marketing and branding will want to come to this Lunch and Learn. And if you're an entrepreneur and you want to get a product out there, you're going to want to come to the Lunch and Learn. It's at Advent Co-working. And we're doing these all as part of the Riot Group in partnership with Charlotte IoT. And if you've never heard of the NC Riot Group, it's a group of 7,000 IoT people headquartered up in the Raleigh area, and they do things like the accelerator program where they take entrepreneurs and they help mentor them make products and things like that. And their accelerator program, it's this next round is still open for a little bit of time. So if you guys have ideas on like products you want to take to market, don't quite know how to do it, maybe it's the marketing side or maybe it's the technology side or something like that, then I highly think you guys should talk to the Riot folks or talk to me. Yeah?
How developed do the ideas have to be? Like, can it just be in the idea phase, or do you have to have like...
Yeah, no, I think you can take, as long as it's a good idea, I think it can just be in the idea phase. Yeah. Yeah, I'll give you their contact later on. So we went to the Maker Faire, and we had a killer time. We had over, I think, 20 volunteers, and just really fun. We did a workshop. And the Maker Faire in Charlotte has dwindled a little bit in attendance, where the first year they had 4,000, and they're down to a little more than 1,000. So the leadership has talking to our leadership, and we're wanting to make this thing big again, and we want to make it awesome. And so we want to start like a year earlier than what we started last year, because we kind of threw everything together, and people like Joseph made really cool postcards of Charlotte IoT with all this really great information, and Mark made big signs. But we want to be a lot more organized and do it way bigger and better and fun. And so if you guys want to help with this effort, then please come talk to me and the leadership team, and we'll figure out how you can help with it. But if you guys know makers, we want to get them all involved and just do more with that. And Jeremy, if you could, yes.
Several of the high schools like Olympic and Harding have career speed dating events, if you will.
Yeah.
And that would be a good in for us to give back to them, and also promote the Makers Fair.
Yeah.
Because they're the STEM schools, if you will. Or
that would be cool. Yeah. Come hook up with me after this, and we'll see what we can do for that.
Yeah, I think, I don't have my calendar, but well, I do have my calendar, but on the 18th and maybe...
Of November,
16th.
or?
Yeah, I think Harding's on the 18th and Olympics on the 16th, or something to that effect. I know I was debating on going to Harding, but it's a long drive for me, early in the morning.
Yeah.
But Olympics not bad.
Okay.
And I've done it before, and it's fun. And a lot of the kids are interested in IT. And a lot of them have the robotics and stuff.
Yeah, yeah, awesome. So Jeremy's been leading our civic hacking, and he's been doing like an amazing job. And all of a sudden, work became like really burdensome for me, and it's like I can't even help. And Jerry's been like, "Don't even worry about it. I got this." And it's leaders like Jeremy that are killing it and making this like a really great organization. And I don't even have to help with anything, and he's just like killing it and doing amazing stuff, and really, really, really appreciated. Could you give an update on the civic hacking from Saturday?
Yeah, so we did a little bit of Alexa stuff. So we're doing an MP3 player over Alexa.
It's fine, Jack.
And we had a great time. We had a small group, and we're hoping to do it again January, February, sometime in that time frame, and put the rest of this together. These are just great opportunities for us to get out and take all the knowledge we learned here, apply it in the real world, and actually do something to help people. So it's a great feeling, great project, and I hope you guys can come out and help.
That's awesome. Thank you, Jeremy. Yeah, I mean, where else can you learn something and also make someone's life better at the same time? And these things that we do, like we worked on a blanket that we Alexified so that a paraplegic can heat or cool the blanket from speech instead of waking up his family to, in the middle of the night. So we're doing things that are helping lives, and Jeremy's just doing an amazing job with this. It's much appreciated. Our next month meeting is going to be epic. It's not posted on Meetup yet. We're going to do another field trip, and this one's going to be at Microsoft. And we've got a big shot from Microsoft coming in town. By a big shot, I mean like a rock star. He's on Channel 9. If you guys know what Channel 9 is, it's Microsoft's technology channel. And like he's like constantly on it. You won't want to miss this. It'll be at Microsoft. And we can either have subs or pizza. Do you guys care which we have for dinner that night?
Subs.
Subs? Yeah, raise your hand if you want subs. Okay, I don't even ask for pizza because everyone raised their hands. It'll be Subway. But anyways, tell your friends this will be a big event, and it'll be fun to do an outing. And now the prime event. Brian Vinson, Jeremy has worked with him at LendingTree and hooked us up with him, and we're just really stoked to learn about the Google Cloud. And I mean, you'll probably give an overview on your background. I know you've worked at SAS and you've worked for Oracle and done some epic things.
Thank you.
Yep. Thank you, Brian.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Testing? Good? All right, so how's everybody doing? Good. Sorry for the delays there. Just by way of introduction, I'm Brian Vinson. I'm a customer engineer here with Google, and I've been at Google about 1 year and 3 months, I think, to be exact. My background has been heavily focused in IT. I actually started in analytics at a SaaS Institute in development, moved to Oracle and pre-sales architecture for about 11 years or so before coming over to Google, focusing on Google Cloud. And before I focus on the presentation and got some demos and a couple giveaways here as well. One of the things about Google Cloud is it's a pretty broad subject, right? So it's not just infrastructure and platform as a service, it's IoT, it's big data, it's machine learning, it's G Suite and collaboration tools and Chrome and Maps. So I've got a pretty big bag of products and services that I cover, IoT being one of them, which we're focusing on today. So happy to do so and talk to you about it. Also as a part of that, we've also got Microchip here, which is going to talk through some stuff that they're offering and some of our integrations, which are pretty nice too, which I think you'll enjoy. Let's start with Cloud IoT, and I know this is an IoT group, and I'm actually curious on one point, just quick show of hands, how many people have built something with IoT already and connected it to some cloud resource to do something in the cloud as well? All right, so about half people overall. Saw a couple hands when I said cloud go down. So you built something in IoT, on-prem as well with some kind of a laptop or something, doing something to it, I assume, or a controller. Our strategy is pretty comprehensive. It's giving an integrated solution, integrated suite of products and services that allow you to do these really nice IoT things, add things on it like machine learning. One of the things we focus on at Google, specifically in the IoT space, is scalable, no ops, serverless, every other sales buzzwords you can hear in that space. But in theory, allowing you to do IoT, connect devices, but not have to worry about virtual machines and CPU and RAM and all the other things that come with infrastructure. So we try to give you services that you can plug into that scale automatically as loads come across, so you don't have to worry about all the technical parts behind the scenes, but can focus on the IoT part, connecting your devices and doing something with them based on sensors or whatever the case is. One thing about Google, you see infinitely scalable. I'm from the technology background and I hate the word infinite because it is scary as all get out, right? So about Google, so I don't focus on this much in the presentation, but we have a very, very large presence from just an infrastructure, data center, networking perspective. We are one of the top 10 builders of chips in the world, and actually you can't purchase any of them from us because we actually do it in our own data centers that we built as well. We built our own fiber connectivity, deep sea channel cables across. We actually just finished early this year was Hong Kong to LA, so direct connection, fiber connection, undersea cable. We're actually the only provider that does that in the cloud space. Technically, I think Microsoft has a partnership with Facebook, so there is a deep sea cable. They have one. We're up to like 7 or 10 total at this point. So infrastructure is big. We scale. We're always creating servers, always building chips. We do things like take graphics card out of them, so you don't have to worry about slow processors and things like that. Enough of that though. So kind of getting back into the IoT space, we do it in a couple ways. So you can actually do IoT with us on-prem. You can connect to the cloud. I'll talk through how you do that, what those cloud services look like. And then end-to-end security. We are very big on security, try to stay out of the news for obvious reasons, because people trust us with their data. And it's a really big deal for us. I did see a hand go up there.
Yeah, I know I can use GPUs in the cloud from various vendors, and I'm assuming Google. Can I use ARM equipment and things that represent the IoT devices? Can I find them in cloud as a platform as a service?
All right, so the question is, you can use GPUs in the cloud, but can you do ARM equipment in cloud as well? So things that connect your device as well, right?
Well, running, emulation, not emulation, but on a real device in the cloud, can I get so many ARM 7s and whatever, like I can pick a server with GPUs. Can I pick a server that has access to Raspberry Pi?
Can you pick a server that has access to Raspberry Pis? It depends is going to be your answer. Let me explain. So in the cloud, we provide CPUs, we provide GPUs, which you're referring to. We have a number of different GPU variations, and we also have something unique to Google called a TPU. So you can't get that anywhere but with us. I'll explain what that means and then I'll answer your question directly. A TPU is a tensor processing unit. You'll see about 15 to 30x performance increase on those. About 10 to 12 years ago, Google hit a point where we realized if we kept building CPUs and leveraging GPUs, it wouldn't scale. There was a fact back then 10 years ago that said if everybody spoke into their phone for 3 minutes, every Google server would crash because there was just too much capacity. So we tried to get around that. We put a very, very big multi-billion-dollar investment in TPUs, meaning we can process them faster, we can do more machine learning on the chipset direct, you can only use them in the cloud. For devices, and we'll talk about this in the IoT space specifically, you can get as many GPUs and chipsets and servers as you want. We have no problem with you adding more and paying for more. You can be our biggest customer from that perspective. What you see in the IoT space, though, is it depends on your device. So a lot of times you'll see we like to have controllers on the device direct, right? So you prevent some of the latency. We're doing some things around TPU edge, which I'll talk about in a minute, but we commonly see people put control access type devices in the cloud and deploy those on VMs or deploy those serverless. A lot of the other stuff we like to see local to the device, and then we send messages back and forth from the cloud to the device for communication. Benefits of IoT, benefits of cloud. So it goes across a couple of ways. Scalable. We don't ask you to do any workload testing. We actually, whatever you process through us, whether it be multiple messages at one time, or if you go idle for a very long time, the whole benefit of our IoT platform is it scales as your messages, as your sensor devices coming into the system scale as well. So if you need a wide pipeline to process a lot of events at one specific time, those CPUs, those GPUs, TPUs, whatever your chipset is, they'll scale out just enough to process that, and when it's finished, it scales back down. So it's completely serverless and scalable. It's all auto scale out of the box. I won't go through all of these points, but the big piece here is that you will save money doing that, because in cloud, you want to pay for what you use, and you don't want to have idle hardware just sitting there. So when you're not using it, quite candidly, why worry about going through the process of having to pay for it? So when you scale to zero, you pay zero. When you're using machine learning, whatever the case may be, when you use it, you pay. When you don't have to worry about idle hardware sitting there processing TensorFlow logic or whatever the case may be. So customers, what are people doing? So we see a lot of things in predictive maintenance. I have a heavy interest these days in robotics. So at Google, I don't know if anybody's ever, just by show of hands, anybody heard of a 20% project? Anybody familiar with Google culture? All right, so we got 2 or 3 hands. So at Google, we have a concept of working on things you're passionate in, and you can dedicate 20% of your time, 1, 2 days, whatever days a week, to kind of do something you're interested in. So this whole Chrome thing I'm working from, the Chrome browser, was a 20% project internal to Google. There was another browser out at the time that wasn't really going as fast as they wanted it to. They built Chrome, worked great internally, got released. The Gmail features, like auto responses, I don't know if you've seen it, actually looks at how you respond to messages and gives you 3 options. That was an actual April Fool's joke in Google. And nobody thought that would actually become a real product, but it became a 20% project, which launched into something that you're using, and now it's actually taking another step where it predicts what you're going to type as you're typing it. So I can literally hit tab through most of my emails at this point because it knows how I talk, right? So those are 20% projects. The reason I go there is one of mine is actually robotics and IoT. So one of the demos I'll show you here is actually based on where I'm spending a good bit of my time in the robotics space, IoT, connecting devices to sensors, and processing machine learning and logic. We commonly see predictive maintenance. Robotics is really big. Visual intelligence. Maintenance is really big because we're seeing this in a lot of different spaces, whether it be putting sensors on tires to see when they're going to wear and tear before they actually do and be predictive about that, or reminding customers to go get their tires rotated because they see the sensor and they see the tire wear. Oil rigs is very common in this space as well, so it's becoming a pretty big thing in the IoT space. Kind of summarizing the IoT platform, and then we'll get into a couple products and then a demo. Remember, serverless by design. We try to do AI in literally everything we do, and there's probably not one product I can think of that we haven't put AI in or has a roadmap to put AI into it. Consumer-wise or enterprise-wise, it's a really big deal for us. So a lot of things you'll see in the IoT space for us are based around artificial intelligence and processing things quickly with machine learning. Second part of this is IoT Edge, and what we mean by that is trying to get to a point where we bring the machine learning to the device or to the user, as opposed to using the cloud to do all the processing. So this is becoming very, very common, not just in the old days of kind of putting the controllers and having controllers communicate, but actually running the TensorFlow logic on the device itself and only communicating with the cloud when you need to for speeds. And that's really good for bandwidth, for latency, any device that you have out in the field, and for privacy. What we're also doing now is putting machine learning there as well. So anybody in the kind of building things in the space, you're familiar with like an inference or an inference VM or whatever you do to kind of do your IoT and your machine learning. We're doing faster inference with TPU Edge by actually putting it on the device. The device can run Android, it can run TensorFlow Lite, and have all of the logic on the device itself, connect to IoT in the cloud for low latency when you need it, as opposed to depending on the cloud for the communication part. So what is that? So Android things is actually taking off these days. Linux-based operating systems can support this as well. We actually sell, well, we provide the TPU chips, the ASIC chips if you need those as well, to run those local to your device, install them on your device, and kind of go from there, and connecting to the IoT cloud, which is a very easy process, and we'll talk about that from some of the microchip stuff in a minute.
What are TPU chips?
So tensor processing unit, so CPU,
What goes on
GPU, TPU. We actually have TPU chips that you can actually put on the device, which would run TensorFlow Lite, it would run Android or Android things, Linux-based operating system, and then communicate back to the cloud.
So it's pretty much what you put on individual devices.
Correct.
And the cloud will control the devices.
Correct. Yeah, and you don't have to put it on every, it's really up to you, but we do provide that now as a part of the Edge process. Every person who does IoT with us does not always use the IoT Edge aspect of it. It really depends on your use case, but if you have heavy machine learning that you need on the device itself, this is kind of one of those things that's a differentiator in the space that we're doing.
Question?
Yes.
The Android things, I think I've heard some seminars from your guys on that, and what I got from it was that it was a platform much like Microsoft's Windows IoT Core for Raspberry Pi, where you took a large computing model and you built it and you put it out on a device. And two of the limitations I saw in that was if I'm going to build Android for a targeted device, the first thing I need is a board support package from you guys for the device. And the second thing is I'm also going to be putting a large amount of libraries and stuff on just to link the Android environment. Whereas if I'm building natively, if I've got a Raspberry Pi and I build natively, I can put a lot of apps out there versus putting just one app in a kiosk model. Can you, were you planning on talking more about Android things?
I wasn't. Actually,
Okay.
my device is running a Raspberry Pi, so there you go.
Okay. All right, so you're not selling that?
No, I'm not. But it does have some very specific use cases that work wonders, right? Depends on what you're trying to accomplish. And the question was really around Android things and differing from Microsoft's IoT and Raspberry Pi integration. we integrate with Raspberry Pis as well. So don't think of Android things as our only solution. One of the things that I value here at Google is we are a very open vendor. TensorFlow and all these different things that we've released to open source. So we don't really shove a specific approach down your throat. We actually just allow you to choose from what's out there, right? So features of IoT Edge, just kind of summarizing this point to go to the next one. Local compute, so when you don't want to depend on the cloud for anything. There are some Edge TPU support here as well. Running machine learning inference on the device. So if that's a requirement, that's when you look for something like this, because it makes a ton of sense for latency and processing, and then connecting securely to the devices as well, which we'll show you some of that in a little bit here is also. It is a lifecycle part. So you can go from the Edge device to the Google Cloud, and we'll talk about the various components. And think about machine learning and IoT. Machine learning is always learning, right? You're always getting more out of the model, you're making it smarter. And it starts to do things like predicting if you build these models correctly. So the good thing here is you can locally store, you can process this on the device, do the intelligence at the edge, but then communicate to the cloud and have that roundabout trip from the IoT perspective. The last part of this, before getting into the demo, is IoT Core, which is really the basis of our IoT platform. This is kind of the driving factor behind it. This is what people are doing in the IoT space, and it causes a lot of the integration. So it consists of two components. There's the protocol bridge, and there's the device manager. The protocol bridge is where you do things like your MTT protocol endpoints. I'm sure everybody who's done an IoT device here has kind of done something in the MQTT space, because it's probably the most common protocol we see. And then the device management. So not trying to manage individual devices. I have one device here, right? What if I had 20 of them? How do I control and manage all 20 of those without logging into each one individually? I use the device manager. I register those devices, and now I can push the update to the device as opposed to going to the device to do it individually. So one of the big benefits of the IoT Core platform. We also do monitoring from that as well. The second part of this, IoT Core, serverless, scales on demand. PubSub is our messaging queue. If anybody here has done something like Apache or Kafka, very similar to that. But it's managed by Google. We do all the scaling, all the infrastructure to it, streaming messages into the cloud, ingesting those messages, the concept of topics and subscriptions. So you push your messages from your device to a topic. You have other services that subscribe to that and do something with the data, whether it be putting it into a repository, doing some form of reporting on top of that. Question in the back.
Is this MQTT capable, and how does it compare to MQTT? And does it support like ghost devices?
Yes. So kind of thinking about it this way. So let me kind of do one thing here and go to the architecture. So is it MQTT capable? Typically when we have an MQTT requirement, Cloud IoT Core is the front end to that, and then it pushes that to PubSub. So it's kind of a suite of products. So MQTT is IoT Core. PubSub is just a component of that service or that product. So second question was what after the MQTT capable part? I want to make sure I capture the second question.
Does it have like ghost devices or
devices that were not registered?
That's an Azure thing for pairing
Device
in the
twin.
cloud
Azure
the device and so you can look at the device and what its current status is in the cloud as well, because it's getting that information exchanged over its IoT.
AWS has it too. It's a way of storing device state while the device is not attached.
So can we store device state while the device is not attached? Yes. So that is, but that is not the PubSub part. Again, that's back to IoT Core. So I'm trying to show differentiation, but yes, we do that to answer your question. All right. So IoT Core, you'll see a lot of moving parts here. I'm not going to go through all of them because actually the demonstration actually touches on a lot of these products, but every product at Google has a hexagon, and we're up to 65, 70 plus hexagons and growing. I could go through product for product, and we wouldn't have the time to do so. But keep in mind that this is an integrated platform, right? So you're going through IoT Core as the front end. IoT Core can quarterback this in a number of ways, right? It can send the messages somewhere, it can send the data to a repository, we can do functions and serverless actions from there as well based on what you need and what you require. The other thing is everything we do is API driven, so we don't always require you to come into an interface or a console. You can script this if you choose as well, which is a very common requirement we see quite a bit. Another question, yes?
Do you have your own time series database, or are you integrating other people's?
We have, yes, plenty time series databases, yes. So our more common one these days is we see a lot in the big table space, which is time series, but it's also NoSQL. We actually leverage that for maps, search, ads, things like that. So one of the things you'll notice about Google is a lot of the products we have and services we provide are things that we actually use internal to our customers, and then we put those as services for you to use in your business. So end-to-end data processing, Android things, IoT Core, process and clean that data through various ways to do storage, whether it be a repository or a pipeline, and then visualizing that. We didn't get into the visualization part. I wanted to focus more so on the IoT part, but we can do a lot around visualization as well. And exciting new features in IoT Core. We'll leave this behind so you can kind of go through the process if you want to look at it, but we've really focused a lot on onboarding because as people come into this as a new product, we want to make sure they don't have to go through a process of taking hundreds and thousands of devices and individually registering those. So we try to automate the process of onboarding millions of devices at a quick time frame. So that's one of the newest features we're getting a lot of requirements around. You can see the high-speed cloud device messaging hit 100 messages per second at each device at high speed, which is pretty phenomenal. And then security around gateways and things like that. So, yes?
Android things, this may be a stupid question, is that like an app now that you can have, or?
No, it's truly the software OS that you put on a device, whether it be, and we're actually seeing a lot now on even.
It's more like a business software that you order, can individual.
Oh, you can go try it now. It's not going to cost you anything to go kick the tires. So, yeah, if you want to put it on something, feel free. It's easy to start deploying. There's a website. It's usually on our Google developer.google.com. I think is where you get most of the info on it. But it's really easy to start going with. So all the various parts of the platform. I'm going to actually skip through this and kind of go through some of the demonstration as well. And this is building a self-driving robot. So one of the things we spent some time, and I'm actually going to power up the car here as well, but one of the things we spent some time doing is trying to come up with a way to build a robot and make it autonomous. So a self-driving robot that can find balls of any color based on the machine learning model that we built, go grab the ball and then take it to a letter, right? So very simplistic idea, you'd think. But we went through a lot of iterations. All the hardware, everything that we did, and I'll have the car up here in a minute to show you, is actually listed here. Total cost of the car to build is about $250. We've actually put up a website for anybody who is interested in trying this. Reach out to me afterwards, I'll give it to you. That has a step-by-step directions, the links to order each part, how to build it, how to go through the machine learning in the process and build it in Google Cloud on a free trial. So it's really nice concept, but there's a robot and then there's a software, and we've been doing this as a lab, or what I call almost like a hackathon, half-day event. I was in DC just 2 weeks ago. We did a pretty big event, and I think I've got some pictures up here as well, but we wanted to make it a game and we wanted to make it a competition. So how do you have an autonomous car create a game where people get excited? Well, that was where it took a lot of time to think about this. So each team, we came up with this concept of a derby, and each team would build a car and have a letter, and their letter represented the color balls they were collecting. And we throw all the balls in the middle of the table, and they tell their cars, and they turn them on, and their cars have to go find each ball, turn around, find their letter, bring it back, drop the ball. First team to win gets a Google Home for everybody on the team. So you can imagine how competitive these things are. It's pretty intense. So we built it for a couple reasons. So we wanted people not just to worry about building the robot, but actually building the logic behind it. So we overdid the logic. for obvious reasons. So normally what you would do on a car like this is you would put the controller on the device, but not us. We put it in the cloud because we wanted people to develop an app in the cloud and see how easy it was to port that out. We could have just done this in IoT Core and done the whole thing really quick, but we wanted you to touch all the products. So it goes to IoT Core, sends messages to PubSub. It actually stores it in a storage bucket. We use machine learning and a camera on the device to take pictures constantly, upload those pictures and process them to tell what kind of ball you actually have in front of you. So it's a very intensive process, but we wanted people to touch all the different products and get a feel for what was out there. So we overdid that a lot, but we want to show people the power of GCP. Here's actually some of the stuff we did. Our first one was actually in January, up in DC. You see the top left corner here, everybody is just in a circle on a carpet, and there are some letters behind. You see the C, the A, the B, and everything. And we just put the balls out there, they got their cars, they went and got them, worked, right? 2 weeks ago, we got really elaborate. I didn't take a picture of the whole room. We had about 5 of these tables with the logo. We had lights flashing and chairs, and it was pretty nice setup. And we built about 25 cars. So you can see them all lined up. The day before, I installed personally 10 of these out of the box. So you can imagine my day prior to. Yeah, funny story. So everybody wants to help because it's cool to put a device together. And I had a couple sales reps come up and they're like, "Hey, Brian, can we help you?" And I said, "Well, yeah, can you follow these directions on my laptop and word for word install the car?" And it'd take them like 2 hours, and they finally finished, and it was so awesome. And at that point, I'm not using directions. I'm like 6 cars in, just throwing them to the side. So, but yeah, so it takes a while, but I've made this fun. My son actually built this car. He's 10. So the car you actually see here was built by him. He wanted to do something cool, so we did a little father-son project, and I let him do all the work. So he built the car we're actually going to show here today. The implementation is the robot hardware, robot software, APIs on the car itself for those who can see, and there's a camera here as well. We've got a couple of really interesting things going on. So we have motors on the bottom, battery pack. We have a Raspberry Pi and a board on the top, and on the front here is actually a camera, and then on above that is actually a sensor. So the sensor detects when you get close to an object, when to stop. Even if you tell it to keep going, it knows I'm too close to continue, I must stop, right? So to have a self-driving car, the number one thing we had to do is figure out a way to get a sensor on it, because otherwise there would be trouble. You'd be crashing and everything, and we don't let people keep the cars, so we didn't want them to also break the cars. So with that, there's navigation logic. The navigation logic tells it where to go, and there's an administrative UI. We're also very specific to make sure we focused on the security implementation. So the car works off of a service account, and that service account is authenticated to only talk to specific resources in the project that it has access to, right? So we can restrict that, we can grant that based on what we felt was comfortable. With that, there's a REST service, there's PubSub, that's a really big part of this, and then there's the controller. So each time the car sits, it's actually going to take a picture, upload that, and you can actually see that in real time. So with that, I'm actually going to get into the demo. Before that, I'll kind of leave this one slide out, and we'll leave this behind too. Everybody here, you get something when you leave. You got $300 free credit. Just got to put in your credit card that we won't charge. So if you ever want to go try anything on GCP, just go log into this website. You get $300 to use for 12 months, so you can take your time. Also, November 28th, we're going to have a cloud onboard, Google Cloud onboard, which is a really big deal. We fought to get this in Charlotte. It's hit the major cities, but it's going to be at the Le Meridian Hotel, November 28th, all day. It's free to register, and you get food, breakfast, and lunch. And we negotiated hot breakfast because I like to eat. So everybody, please come if you can to that as well.
What's going on with this?
So at that, I probably should have gave more detail. So that's actually free training. We're giving overviews of everything from IoT, big data, machine learning, infrastructure, platform. We're going to have demo booths outside. The Derby cars will be there as well. You'll see those competing outside the door. And also we have giveaways, competitions, t-shirts. Everybody gets a t-shirt as well for coming and enjoying the event. So more the merrier. So if you want to invite more people from your company, pass it on. I'll leave a link behind. I guess I can leave that with you guys and forward it out to the meetup from there. So with that, I'm a Tommy Boy fan, so the demo. All right, so I'm gonna do a couple things here. And the first thing I gotta do is actually log into the car. And I'm actually running off of a hotspot, so if you see any performance degradation, that's why. My super secure password of robots. 1, 2, 3, 4. All right, and now I'm actually gonna log into the car. I'm gonna run the script to start it up. So with that, I'm actually, while that's firing up, I'm gonna do a couple things. I'm gonna show you the devices that are registered. And actually, here's our IoT core. You can actually see I have 2 devices registered. One is actually my car. The second is actually my chipset here that we're going to talk about from my friend Microchip. So one of the things I did before coming over here, I actually hooked this up, and it's all set up to send messages to the cloud as well.
Are you able to bump the font size
Yeah,
up? A little bit?
very good. Very. Can I bump the font up? Yes, I can.
Okay, nice.
All right, and now I can actually see it too. So if you go to the car registry, you can look in here and you can actually see the various things the car is doing. I can create devices. You can see now my car is actually ready because it lit up, which means it's ready to take commands. And actually right now it's in self-driving mode. I don't really have enough space to put balls on a table and have letters and things going back. So I'm actually going to take it out of self-driving mode and show you some different things that we can do with the car. But if I wanted to put it in manual mode, I literally click manual, I refresh. And now, as I refresh, this actually is taking images. So when it's yellow, it's uploading an image. It uploaded an image, and now you can actually see in real time, well, the socks on the left and the letter B ahead of it. So if I put more things down on the screen, it would do that. So every time it lights up, it's actually going to take an image. So with that, I'm actually going to do something interesting that I added literally 10 minutes before I walked out the door here. So I actually put voice control on it. So since I can't do the self-driving part, I'm actually going to do the voice control part to show that it can take commands. So here, if I were to type something, let's just say, I'll see if the microphone works, drive forward 3 feet. And it takes the command in real time, so hopefully that table's 3 feet. All right, I got a little nervous there. All right.
What program is this? Is this
This, so,
or is this the Android IoT?
This is neither. Well, the device is running Raspberry Pi, right? So there's a Raspberry Pi. We've installed the Google SDK to it. So
is that open source program?
This is all open source. This is all open source, yeah. So nothing here is paid from that perspective.
You don't have that much technical knowledge to do stuff like this.
No, my 10-year-old can do this now. So yeah, yeah. But yeah. So it's all open source. Only thing is it's tying back to the cloud. So it's using cloud components and mechanisms as well. The program you actually see on the screen here is Dialogflow. So I know you guys did some stuff with AWS and Alexa and things like that. This actually integrates with Alexa, Google Home, whatever else, Facebook, Twitter. So it's out of the box native integrations, but I can create voice commands. So I've just put steps in here to say, if I tell you to do this, that relates to something on the back end to take the command, right? So one of the things about the car is it actually had, and then you can see it's yellow, so it's uploading images. So if I actually went back to that previous page and did a refresh, I probably would see that B is a lot closer now, which it is, and I could adjust the camera and I could see different things from there. The other thing is there are 2 wheels in the front and there's kind of a spinning piece on the back. So if I said, let's say turn 180 degrees right, and it completely turns around, right? So I can tell it to go backwards, I can tell it to go forward. I can do things like control the gripper. So open gripper. And you see the gripper opens up as well. So I can program this to do a number of things, right? One of the things we're actually doing as a part of these demos now, and I could do this stuff for forever when go over time, obviously, but we actually put signs down and say, hey, read the sign. And it'll actually use the camera, read what's in it, and actually say that out loud on the computer or your phone or whatever the case is. This is a web demo. If I were to push this, I'd do these same commands from my phone or a device, and it would command the car the same way. The really nice thing about the car is when I put it into a self-driving mode and do a game, I don't tell it anything. I literally go in here, and I'm actually going to disable it so I don't have the car going all over the table. So kind of work with me in concept here. But I would go in here and I would say, go into self-driving mode, and now it's ready to go in self-driving mode. I specifically did not put any balls on the table because it would try to go get them. And I put, you know, instead of going for the yellow ball, go for the blue ball. And I would submit that. It's now looking for the blue balls. And actually on the device, you can see all the stuff that's happening in real time as we go from the cloud to the device. So it's back and forth communication. First question was here, actually.
Yes. So the only experience I had with any of this was like an Arduino. You have to enter in all the code, you know, to make LEDs turn on or whatever. So this allows you to enter more like verbal commands and like enter it in like kind of normal language without having to know code and write code.
Correct.
Okay,
so
it kind of makes that dummy-proof to where it kind of bridges that gap if you don't have the technical.
Yeah, and one thing I didn't touch on was the API. So we have machine learning APIs. One of those is the vision API, which the camera's using. So it's identifying objects, red ball, blue ball, yellow ball, B, whatever the letter is. We also have voice and speech APIs. One of those is called natural language API, meaning I can talk to the robot as if it's a person. It understands sentiment and what I'm trying to relay to it, and changes that into a command, right? So I don't have to program all that. That API is called natural language processing, NLP.
What's the API?
I'm sorry, so API is, it's a way for you to call a specific service that we've pre-built. So instead of creating these extensive machine learning models, we built it internal to Google, and we've actually packaged that up in a way where you just call a service via web service or integrate it into an application, and you could use what we've already built to do what you want as opposed to writing it. So when I leverage natural language processing or vision, I don't have to go build this myself. I just say, go get it from this, tell me what it is, and let me do something with the result, right? So in the programs that we wrote for this car, it was, is that a red ball? Yes? Okay, go grab it. Once you get to this specific distance to it, open your gripper. Once you get to this specific distance to it, close the gripper. So go find it.
The API is this program that's interpreting that, writing the code, and then making it do something.
Yes, with a lot more moving parts because we complicated it so you can use a lot of products. So, yeah. But this is all in a GitHub.
The API has to be written for each individual device, though. I mean,
no. So,
like if you didn't have a robot API written, then it would only be able to control a device that you had written, right?
If I didn't have a robot written, it would only control a device.
I'm not asking that right.
Actually, no. So let me take a step back. So let's just say I had 2 more cars right here in front of me. What I could do that's actually really interesting is I build those cars, I register those cars as devices in my Cloud IoT core, and now those cars can now have the same logic, right? Because I'm now pushing the code to the device as opposed to creating something new. So we keep it very generic. You just register the device, and each device you register then inherits the code for this program. So we have one specific base of code for this use case, but we had 25 cars. There's no way we were going to do that one by one.
But like when you went into manual mode, it had all those things that you could enter in.
Yes.
If that API hadn't had that written into it, if it had a different device per se, then like those commands are specific to that device.
Correct. So this controller is for this car. So to your point, this is a website. This is a controller that you see on the screen specific to this device. This is the way we built it, right? I could have easily said, do I want to send this to all 25 cars? Yes, and have them just go at the same time, and then that would be just chaos, right? But for the exercise, what we wanted to do is separate each device to have its own controller where each team had freedom to do what they want, which is why we kind of built it that way. Question at the top.
I think the confusion is coming in where the expectation is that you could write natural language to build something where realistically what you're likely doing, if it's anything like Alexa or anything else, you're building a template for the language you're using. And then it's parsing out what you need, and then it's pushing that to some code that's actually controlling a device.
Correct.
So we still don't have natural language control over IoT devices without some level of...
There's some form of translation you have to do to make it make sense for the device.
Controlling the device itself.
Correct.
So I couldn't make a device from scratch that didn't fit into these parameters and just say turn left or pick this up or anything like that.
No, because somewhere there has to be a translation of that 3 feet is, I don't know whether you're using the distance sensor or the actual motors of
let me answer that question.
Roll the wheels this far.
So the logic in all this is really for us in the fulfillment, which is code, right? So what's the car? What's the password? How do I get into the car, right? This is all the logic behind this passing logic into the specific car, the specific device. So there is some code, but the APIs make it easy from the sense where I can now talk into it, I can type into it, I can give it a command from an interface, or I can just say, go be in self-driving mode based on what I've built.
Okay.
Question here.
So how much of the vision is running on the car's Raspberry Pi and how much in the cloud? And can the vision do complex things like, can it run the game program with balls on the table and sense the edge of the table and not drive off? That sort of thing.
So the question is, how much of the vision API is on the device versus the cloud? All of the vision functionality is actually in the cloud. What we're doing on the device is simply taking the pictures and uploading them to the cloud, right? That's only because the controller is in the cloud, which we would not do in a real life situation. So to kind of simplify it, if this was a real car that we wanted high speed, we wanted it to respond very quickly, all that logic, we would actually have that controller in the car and communicate to the cloud when necessary.
Does the Raspberry Pi have the capability of running the same quality vision algorithm and autonomous driving program as?
I'll stop you there. Does the Raspberry Pi have the ability to do that in a high-speed fashion? Probably not. The car is very simplistic, but the car can do that processing. If you had a very enterprise-wide solution or car or something you're building for a real competition, we would beef up the cores or the processing and not use a Raspberry Pi. But for the sake of this specific use case, Raspberry Pi works great. We actually could have put the controller on the Pi and probably just changed the code a little bit to be a little more optimized. But for this sake, we wanted people to use the cloud.
Can I use your TPU chip on that Raspberry Pi and oomph increase the...
Can you use the TPU chip? You can use our Edge TPU chip on the Pi if you needed to and extend that, yes. So with that, I'm not going to eat into a bunch of time here, but that's the whole concept of this. And as I talked into it, I can also type into this as well. So I could have said, what did I type? What did I actually say before? I said drive forward 3 feet. So drive forward 2 feet. And I had to make sure I checked the number so that I wouldn't drive too far. But if I were to do that as well, I put the command in, and it's going to say marching forward 2 feet, and the car would move forward. I actually looked like I shut down the program, so it's not going to respond. But yeah, I did in the background there. But yeah, so that's the whole concept. I can power down the car. The other thing here is, as I invite him up here, this chip actually that we're going to talk through here actually could have been placed on this car to extend it, which is actually really nice. I actually had some stuff I was building before I came. We actually have, goodness gracious, that was delayed. Hot spots, man, I'll tell you. This chip would install directly to this car, so if I needed something like a sensor or a light detection or anything, I actually would just screw this in, which actually fits the model car I have today, and it integrates right into it and it powers up through USB connectivity. So with that, come on up and we can kind of talk through the rest.
Well, thanks, Brian, for that presentation. I'm Mike Marks with Microchip out of the Raleigh office. I lead a bunch of field application engineers up in Raleigh. And when I saw Brian was coming here, at the same time I knew that was going on, Microchip's been working with Google to come up with a device to just easily get onto the Google Cloud with a couple sensors and build almost like a one-click functionality. You can get on the cloud, there's a couple sensors, you can see it. Once you get that working, all our code is out there. You can create it in Atmel Studio, download all the code, modify it to add other sensors. As you add other sensors, you just get your own Google account, and you're good to go. So it's really straightforward. Some of the values that Microchip brings is we have a couple devices that are on the board, but the key is our secure element, which is basically crypto storage vault. And so when we build these boards, Brian was showing, we got an 8-bit micro on here, our Wi-Fi controller, and our ECC 608, which was built really just a vault for holding your crypto keys. We create a private key that is, when we manufacture the part, that private key is in the device. Nobody ever sees it. It's generated inside the device, so no one can ever get it. From that, we generate public keys that we share with Google, so they know that what the public key is. In between the TLS that runs in the Wi-Fi controller and then the JWT that's created from the private key, Google knows it, and when it connects, it validates the whole process. So the TLS process is generated by just a security code in our Wink device, and then the JWT is created in the micro, and that private key is used to create the JWT, which goes up into the cloud and authenticates the device. So I was going to I don't want to take a lot of time. I just want to show you kind of how it comes up. So when you plug the part in, it mounts basically as a hard drive, and all you do is just click the HTML code. It comes up with the IoT sensor node, and that all show up okay? Yeah. And the first thing it just says is really what, so I'm going to just use my hotspot here, but it just asks for, drop that down, the hotspot. We can type 8. I need to put my glasses on, I'm too old. Get my security code. You download the configuration, turn the hotspot on. That just creates a little config file. You take that and get to the downloads. You drop that onto the board, and in theory, you should have cloud connection coming up. Give it a couple seconds. Every once in a while, we need to just do this. Let me just start it again. Well, all right. Do the reset. Oops. Okay, here we go. And we should connect. There we go. And so on here are there's a light sensor and a temp sensor. So those come up, those are connected, they're in the cloud now. It's all provisioned and knows that this device can legally connect into the Google Cloud. It's been authenticated. You cover up the light sensor. So we were talking about putting this on, it could go to the light or go away from the light. But that's, so in one quick step, you've got easy access to the cloud. I don't know if you've used Atmel Studio. I can come here. So this is how you would load the code. browse examples. This is called the AVR-IoT. Question?
Can you use MP Lab?
Yeah, I don't know if so. Dan gave a quick. So Atmel is Studio, and then MP Lab is a microchip project. After the last 2 years, we've integrated those. So now most of our 8-bit parts and our SAM ARM parts can all be used in MP Lab X, or you can also use them in Studio. But so come over here, scroll down. So now it's going off and building the project. It's getting all the components that are on that board. And from there, you just export the project, download the pack. And I don't know how far you want to go into it, but basically this will create all the source code that's running on here, and now you can start editing it. Also on the board comes a header for the micro clipboards. So there's like 500 different clipboards that are out there. The microelectronic has all the code. So you can drop any sensor board you want on here. You add that sensor to the project. You let Google Cloud know about it, and then you can start displaying other more website images. Yeah. Do you have a question? Or?
Yeah, I saw the I2C library, so you can do I2C devices to there and read them. And
so you can get, so the interface on here is USB. You can get an I2C micro board, I think, that would plug on there and do it that way. So anyway, you can create the project. It'll go off and build a Studio project, and you can start debugging. So from a hardware, that's kind of what we have. I wanted to show you a little bit about what's going on in the secure piece. Actually, I think I may use Brian's. It's coming up.
Change it to duplicate displays.
Oh, okay.
Instead of extend.
Okay. Come on. Go away.
As soon as you start it.
Okay.
Go back to
Oh.
Windows P once you start it.
Oh, when I start the So from here, you just want me to go.
Yeah, go ahead and just hit start.
Start the presentation, or
yeah.
Okay.
And then Windows P to go to duplicate.
Got it. Okay. There we go.
Use that.
So as I mentioned, so the secure element is one of our devices. And as I mentioned, when we fabricate these parts, we put a key is created. And from that key, we can generate public keys. Where's my mouse? I lost my mouse. Oh, I've just, oops. That's, okay. But we generate public keys, and we send them over to the Google IoT cloud platform. So those get stored up there. Now, if you're a device manufacturer, you're making your XYZ manufacturing, you're making devices, you are also, so you get the keys, and you send those into the what Google calls their claim secure elements. So those are sitting there basically. So if you're making 1,000 boards, you send those 1,000 keys in there, until you actually provision and enable those guys, Google isn't charging you for any of that access. Basically, they're just sitting in there until you connect. So also, we're taking that key, we're generating a JWT, which is a JSON web token. The first time you check in, that's basically a TLS connection across there, and that's just also code that's in our Wink 1500. We send that code across, identify that says, yep, this is a valid connection, and from there then we go down and we send the JWT down there to authenticate the MQTT connection.
Do you know how the key is protected in flight and on Google's server? Is it password protected with a PKCS, sign?
So we're creating a TLS link, so that's secure. So that the first check-in is over TLS, and we establish a TLS connection. So then the messages are encrypted going across the TLS, so that there's no clear password.
So aside from SSH, TLS, you're not doing any kind of wrappering with security and passphrases or anything like that?
No, I mean the JWT is kind of the password is encapsulated kind of in there. So that's a password.
Well, yeah, but JWT is after you've claimed that you're using it, right?
Right.
Okay, so just getting the keys in from your manufacturing process, do you verify certificates on both sides? Do you? I mean,
well, it's ECC, so it's private key, public key. So the private key is inside the ECC 608. So that never comes out of the part. All you do is you random number generate, you generate the public keys.
Okay, all you're sending to Google is the public keys?
Yeah, the private key, nobody ever sees the private key. The private key stays inside. You can't ever get it out. There's no access to it. So that's kind of the whole, it's provisioning, and it's very straightforward and simple to get up onto the cloud very quickly.
So if you're doing that in mass, I mean, at fabrication, you have some channel to pass the public keys to Google.
Google, that's
right?
correct.
So like, I come from a wireless.
And it wouldn't be.
We did that.
Yeah, it's
shared secret data, but so if you were building 1,000 of them, if you bought 1,000 of them from you and built them,
right?
How do you get the keys? I mean, it's public keys, right? So you can claim them.
Right. So when you manufacture the parts, and the logistics, but we're manufacturing the parts for XYZ, and we're going to give you a list of those 1,000 public keys.
Just a text file.
Yeah, and it's probably encrypted when it's sent to you and all that, but it's
they're public keys.
Yeah, but they're public keys. So, yeah, but they're public keys, so they're sent, and then you have them. You give them to Google and say, hey, I'm going to provision 1,000 of these devices onto your cloud. Here's the 1,000 public keys that I have. And then once they connect.
And so if you were doing that as an embedded system, I mean, not to say that doing it through the browser wasn't really, really cool. But if you're doing that at scale and you've got field technicians, et cetera, that are deploying these things, how do you do that such that they don't have to plug every one of these things into a browser and go through that process of registration, or do you yet? Are you able to do that, or have you gotten that far and that was cool enough at the moment?
I remember earlier when I was talking about the new roadmap feature. So what he's actually doing here is uploading these directly to IoT Core and registering the device. So we have some ways now to do device discovery. So you've got a list of private keys, you can actually send us that list and do that in a batch format as opposed to an individual device.
So in that, when you powered on the device, if you had an open, communication channel, open Wi-Fi or whatever, can something on the chip be programmed to find an open network, report in, and pull down a config that has that private SSID and authentication and all that sort of stuff, so that literally like a hotspot on a phone, and maybe it's a particular SSID that's that's generated from the phone or whatever. The chip comes on, grabs the open Wi-Fi, goes out, pulls down the rest of its config, and resets without the human interaction necessary.
Yeah, because we can put in the AVR part in there. You could put the Google Cloud web address, and when it found a network to get out on, it would just go to that cloud and then start the authentication piece.
So you've seen sort of the setup of the device, but not the tie-in to the Google side. They do a really good job of kind of giving step-by-step directions on what to do and actually give you pre-generated scripts to run. So you actually copy the code they give you, plug in your project, and it does that automatically behind the scenes. So you actually don't have to physically go in and register your device. The only thing you have to physically do is the public key. The device itself registers automatically.
Okay.
And I want to change that, so you guys actually create a sandbox environment. When you want to change it to your project, GCP, Google.
Right, you claim it and then you get pull them across. Because until then, it's just a manufactured part until you get it.
Yeah. So kind of the next step is if you want to do to your own cloud, not the sandbox. We also work with a company called Leverage. They're a company up in DC that does some of the security stuff, and they kind of walk you through the whole step of setting up the Google Cloud Platform with the Firebase projects. You run the quick start script. You add your public device keys. You update the AVR IoT firmware, and you're basically ready to go. They have a talk to the experts if you need some help, but it's
So at the individual part level for DIYers like this crowd, what do those run?
The board itself or the individual parts?
The board.
I think it's $19 on Microchip Direct on our website.
But if you're lucky, you can win one tonight.
Or two.
Or free.
Yeah. I was going to show one more. Not that one. So just kind of, so this is the device to the cloud. So we talked about the TLS piece that, goes out to the cloud. Server comes back certified. We verify it. Then we create the JWT password, start the MQTT connection with the password. We get the ACK, and then basically from there it's just whatever the device is sending back to you. And I think that's pretty much all I really had. So that's it. Any other questions?
Well, thank you, Michael, for coming to Charlotte. Michael's out of Raleigh. And Brian, thank you for an awesome talk on Google IoT Cloud. We've got some swag to give away, and is Graham here? But he stepped out. So he was keeping track of who was saying the nice stuff on social media. So raise your hand if you said something nice on social media. Okay, so you're 1, you're 2, 3, 4. So it's just the 4? Is there any more? Okay, I'm gonna pick a random number. Oh wait, we've got 4 prizes. But you can pick your prize to the sequence that I get them in. Oh, clip it on? All right.
I did an analog. I said, I've been enjoying PIC processors since I was 23 years old.
Who was number 2? Oh, you did one? No.
You can be 5.
Who was number 2? Jeremy? Come on down and claim your prize. And number 4.
I'll take a bottle.
All right. And number 1? I'm just going to, Mike. All right. Don't forget, next month is Epic. We're going to be at Microsoft, and we have one of the big leaders from Azure IoT. You won't want to miss that, and it'll be a great meeting. Thank you.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.